Nice sunny spring day here in Asheville, North Carolina. And I have a nice bird singing there. In chapter K, we're going to look at rotation. And a nice thing about rotation is that we can understand rotational kinematics by an analogy with the translation formulas we derived in an earlier chapter. So we'll do this by analogy and get those equations written down pretty fast. Then we'll talk about dynamics. Although we're not going to be doing much with dynamics in this chapter, we want to at least introduce it. We talk about what is analogous to force to get something to rotate, and that's going to be the torque. So we make an analogy there. We derive some formulas for rotation to be really understood and analyzed in a later chapter. And then we talk about the distinction between centripetal acceleration. Whenever you move in a circle with constant velocity, you have centripetal acceleration. But when we talk about angular acceleration, we mean the rotation is getting faster and faster. So that means that the tangential velocity is going to increase, but if that increases, then v squared over r increases. So you're increasing the centripetal acceleration also. So the distinction between centripetal and tangential acceleration will be analyzed in somewhat detail. Then we'll look at a race car example where the race car is accelerating according to the speedometer, but also moving in a circle, making it turn. So you have centripetal and tangential acceleration. We'll talk about that. Then we'll do some kinematics with baseball. How many times does a baseball spin while it travels from the pitcher to home plate? What about a fastball? And what about a curveball? Then we'll go to a merry-go-round and look at a merry-go-round with angular acceleration to get it to go, and then with angular deceleration when you let go and it dies down. And finally, we'll do a cool problem with sushi on a vinyl record, spinning the vinyl record so the sushi starts to slide off. So we want to find a coefficient of friction between sushi and vinyl. And we'll do that neat problem, and then we'll relate it to the problem we did before when we had something mass on an incline and then we increased the angle until it just started to slide down. So we'll put this sushi on a vinyl record and have it at an angle and see what the angle is, and relate an earlier problem with coefficient of static friction to a problem with rotation. So some cool problems in this section. And then later we'll have more fun when we start getting into the dynamics, the equations of motion for rotational motion.